Network performance and security are important factors in the switched internetwork. However, having a network with a large number of devices could affect the performance of a network due to broadcast network traffic.
Because a LAN includes all devices in the same broadcast domain. A broadcast domain comprises a set of all LAN-connected devices, so that, when any device sends a broadcast frame, all the other devices get a copy of the frame. In other words, in normal operation, when a switch receives a broadcast frame on one of its ports, it forwards the frame out all other ports, except the port where the broadcast was received. Today there are many ways to improve network performance and security issues. One of the best practices used to enhance network performance and enable better security is by separating a large broadcast domain into smaller ones. By default, switches break up collision domains, while routers break up broadcast domains. That means, routers allow broadcasts to occur only within the originating network, while switches forward broadcast to all segments. Furthermore, a router's primary role is to move information between networks, not to provide network access to end devices. So, how do we break up broadcast domains in a switched internetwork? By creating a virtual local area network. VLANs improve network performance by separating large broadcast domains into smaller ones. A VLAN creates a logical broadcast domain that can span multiple physical LAN segments. It is logical grouping of network users and resources connected to administratively defined ports on a switch. With VLANs, a switch can configure some interfaces into one broadcast domain and some into another, creating multiple broadcast domains. These individual broadcast domains created by the switch are called virtual LANs. VLANs allow an administrator to segment networks based on factors such as function, project team, or application, without regard for the physical location of the user or device. In other words, VLAN segmentation are based on logical connections devices, instead of physical connections. This ensures that two devices can be grouped into the same logical group, even if they do not share the same infrastructure. A group of devices within a VLAN communicate as if they were attached to the same cable, or if a device in one VLAN sends a broadcast Ethernet frame, all devices in the VLAN receive the frame, but devices in other VLANs do not. Furthermore, if two devices share the same infrastructure, but are logically in different broadcast domains, they cannot communicate with each other. However, two devices can communicate with each other if they do not share the same infrastructure, but are logically in the same broadcast domain. Therefore, limiting the number of hosts that receive a single broadcast frame reduces the number of hosts that waste effort processing unneeded broadcasts. It also reduces security risks because fewer hosts see frames sent by any one host. Based on port-based VLANs implementation, there are 6 types of VLANs. The default VLAN for Cisco switches is VLAN 1, and is loaded automatically every time a switch device boot up. All switch ports become a part of this VLAN after the initial boot up of a switch loading the default configuration. VLAN 1 has all the features of any VLAN, except that you cannot rename it, and you cannot delete it. This is because there are some layer 2 protocols such as CDP, VTP, and STP that use this VLAN to carry control and management traffic. But it is never intended to be used as user data VLAN, thus, it is a security best practice to change the default VLAN to a VLAN other than VLAN 1, example, VLAN 50. A native VLAN is a special VLAN whose traffic traverses on the 802.1q trunk without any VLAN tag. A native VLAN is assigned to an 802.1q trunk port. The 802.1q trunk port places untagged traffic on the native VLAN, which by default is VLAN 1. However, it is a best practice to use a VLAN other than VLAN 1, as the native VLAN, example, VLAN 90. Furthermore, this VLAN can be used as a management VLAN. It's obvious that switch could carry voice-based traffic, or management traffic, but would not be the part of data VLAN. Data VLAN is configured to carry user-generated traffic. It is any VLAN, configured to allow switch devices managed via HTTP, Telnet, or SSH. VLAN 1 is the management VLAN by default. Using VLAN 1 as the management VLAN means that anyone connecting to the switch will be in the management VLAN. Therefore, it is not a good practice to use the default VLAN as the management VLAN. To create the management VLAN, the switch virtual interface of that VLAN must be configured. That means assign IP address and subnet mask. It is any VLAN configured, for security best practice, to prevent any unauthorized device from connecting to an unused switch port. All unused switch ports are assigned to this VLAN.
A VLAN enables switch ports to carry IP voice traffic between IP phones. The important point about this VLAN is, first, it requires high bandwidth to ensure voice quality. Second, has higher transmission priority over other types of network traffic. Before configuring a VLAN, it is good practice to examine the configuration of existing VLANs. For example, if you find VLAN.dat in flash memory, that indicates your device is configured with a VLAN. Now, let's create a VLAN, using a global configuration command. Now, test the flash memory, and verify that VLAN.dat has been created. Because it is a local database, for any VLAN created with a normal range VLAN ID. Then, assign the switch ports to the configured VLANs. Before that, verify the access VLAN of the Ethernet interfaces. So, how to forward traffic from one VLAN to another. For example, how to route network traffic from VLAN 10 to VLAN 30.